Hi, good morning everyone. In today's video, we will discuss the subject power plant diesel, and we will learn the basic construction of 2-stroke and 4-stroke engine, the basic construction of starting air valve and the cylinder head with rocker arm. We will learn the basic construction of exhaust valve, cylinder liner, and cylinder head. We will learn also the basic construction of stopping box, proceed bearing, and crankshaft. So let's get started. So today, this topic coverage is intended for this subject PPD with the coverage of week 5, 6, and 7, and this is the continuation of the topic from week 4. So we will start from week 5 as continuation of week 4, the basic construction of 2-stroke and 4-stroke engine. So here we have the starting air valve. So what is starting air valve of marine diesel engine, especially main engine of the ship, the main propulsion of the ship? So here we have the starting air valve. The starting air valve of a marine engine is responsible to start the engine from a standstill or stop position. The air starting valve is fitted at the center or at the side of each cylinder head, controlling the air supply to the combustion chamber at a 30 bar pressure. So that is the definition of starting air valve or air starting valve. So this is the image of air starting valve of the main engine of the ship. So let us talk about the parts, the basic parts of this air starting valve. So here you have you can see the hole in this area. The hole. So this is the pilot air inlet. So by the way, what is pilot air? So pilot air is the supply air or the air pressure supplied to this air starting valve to open to push the piston so that the 30 bar, so this is this pilot air is 7 to 8 bar. This is control air. Control air. So that is pilot air. So this pilot air will push the piston. This piston, this operating piston, you see, this is operating piston. So that in this area here will open. So here in this area will open the 30 bar. So the 30 bar, so later on we will see the diagram. So the 30 bar air starting pressure. Next, we have here the closing spring. So by the way, we will go back to the operating piston. So the operating piston is operated by the use of the pressure from pressure of pilot air, which is 7 to 8 bar control air. So the piston is pushed in this pressure to open the 30 valve, to push down the piston here, and the 30 bar will enter to the piston, to push the piston in here. So we have here the closing spring. So this closing spring will close the piston, or will push the piston up when the pilot air is not available, or it is not open by the camshaft to the distributor. So later on we will see the diagram, and here we have the vent. So the vent, the air is ventilated in this area, in this hole, when the spring will push the piston upward. So the air is ventilated here. We have here also the balance piston. So this balance piston used to when this piston go down, it will open the hole here of the. So this is not the hole that is for the 30 bar, but there is a hole here, imaginary hole here. Later on we will see the diagram. So this is balance piston. This is balance piston. So this is your air start valve or air starting valve assembly. So this is assembly. This one assembly. So air start valve assembly. So in the manual or the engine instruction manual, this is written like this: assembly, air start assembly. Next, so I have here the exploded view of the air start valve of the engine. So this, since when I was ordering parts, I saved this picture in my computer. So now I attach in this video. So this is the taken from the instruction manual, the spare parts catalog or the code book of the main engine which I worked before. So here I will show you, this is advanced knowledge for you. So when you are ordering parts, for example, so this is the main engine code book in my ship before. For example, you are an engineer, marine engineer. So you order spare parts. So in here there is, this one is what we call, this is piston. So I will mark this one. So this is piston. So you have to order this parts because this is already worn out. So you are overhauling your air start valve, and you found out that this part of the piston, air start valve piston, is worn out and you cannot use it anymore. So here you have the reference number. So this is reference number. So you will proceed to the next page. So here you have the number 3. So this is your reference number 3. This is number 3. And this is your description. Sorry, this is not piston, but this is valve stem. So this is valve stem. So you write to your requisition form the reference number and your valve stem. But there is also another way that there is a part number. So here is a reference number. But most of the spare parts catalog, there is a part number. So we will proceed. So in other drawing, we will see another example in ordering spare parts. But here, we will discuss the system which the air starts valve is used, and its working process. So we will read the statement here below. The pilot air enables the compressed air from the receiver to enter directly to the engine cylinders. The distributor valves provide air to operate its starting valve in the correct order and timing. The automatic or remote operating valve allows main starting air to pass to the start valve manifold. So in this statement, I would recommend all cadets or all students studying this video, we will always use the diagram when we study the engine, because in this example, in this statement, it is hard for you to, or it is difficult for you to understand. So we will always use the drawing as well as the diagram to help understand the system. So now I will explain to you. So I will recommend always to my student to study the drawing and diagram in comparison to the explanation. So you have to compare to the explanation to the diagram so that we will understand easily. So now, here, you have here the main air tank. So this is air tank. So 30 bar air tank. Bar air tank. So here you have to open the valve. You have to open this valve. So the pressure, when you open this valve, there is a part of the pressure will travel in this line. So this is called pilot air. This is called pilot air. The 30 bar, so this is pilot air, which is 7 to 8 bar. And the starting air will travel here. You see this arrow. Travel here. Going to there. The starting valve. So the starting air is ready. So now you have here the 30 bar. 30 bar. As you can see, this camshaft is working. This is turning. This is camshaft. So this is camshaft. This one. This is camshaft. So when the camshaft is turning here, pushing this lifter, this is lifter, the pilot air here allow to pass. You see? Just follow this line. You see? There is pilot air in here. So the pilot air here allow, so when the piston go up, you see, when the lifter go up, because of the movement, the pushing movement of the camshaft, the pilot air here allowing to travel here. You see, travel here. So this pilot air will push down the piston. So this is, I explained a while ago that the pilot air will push the piston to the top of the starting valve. You see here, this is the piston. This one here is the piston, the red one. So that this valve will open. You see? So this valve, you have the spindle. This one is spindle. You see, this one is spindle. The one that you see it's opening. So the spindle or the steam valve or the spindle will open so that the air will travel to the piston to push the piston down. You see, you have the pressure of the air here, so your piston will push down. So that is how the starting air system works. So the component here we study is the air start valve. This one, air start valve. This one is the air start valve. So now I prove to you that in studying the system of the engine, it is not enough to read the statement what is written here. It is very difficult to understand. But by using the diagram, we can easily understand how this system works. So remember, all cadets, all students, do what I taught to you so that it will help you to understand. Do not just memorize the statement because it is hard to do that. It is difficult to do that. It is difficult to memorize and you can easily forget. So next, so we have here the diagram. So here, In this diagram, this is simple diagram. This is simple diagram of air starting system. So this is diagram of air starting system. So now we have here the 30 bar. So this is 30 bar pressure. So from your air tank, so it is traveling to the pipe. And this is your air cylinder. Your air cylinder. So we have here it is showing here the local maneuvering stand. So here. So what is local maneuvering stand? Local maneuvering stand is used for emergency maneuvering, which is located at the engine side of the engine. So this is the control of the engine, the maneuvering control of the engine, which is located at the engine side to maneuver the ship when the maneuvering control in the control room and the bridge is not working. So this is local maneuvering stand. And so it's not showing here the maneuvering control from the control room. So here is the emergency. So that's why this diagram is just simple, because of this is only connected to the local maneuvering stand used for emergency. So it is the same. You have here you have the control air. So control air, and you have here the air start valve, which is I discussed a while ago. So you have here the air start valve. And you have also the pilot air. So I already discussed this one. Now when the bridge command, let's say the bridge command is ahead. So this is ahead signal, and this is astern signal. So ahead means the ship move forward, and astern the ship move backward. So astern. So when the bridge give order, so this is the communication between the bridge command to the engine. When this is in vertical position, the stop position. So when the bridge command is ahead, So the engineer used to start the engine will put this lever to ahead. So why I know this? Because I did this job a lot of times. When the bridge command astern signal to the engine, the engineer will put this lever here in the astern. Here. So ES is astern, ES is ahead. So now you have already set the telegraph command. So now you start, followed by starting the engine. So you have to put this lever, see this lever, to start position. So put this lever here to start position, so that the engine will start and move forward. So now you see the signal. The signal, this is wired, this is the dotted line here is, this is wire. So now the signal here travel to the governor. So this is governor, electrical signal. So the governor operate. So governor. So here you have the camshaft. So this is not because this is pneumatic, so this is air travel here, the governor. So this is air, you see, travel to the governor. So I was assuming that this is electrical because of the dotted line. So it might be also electrical, it might be also pneumatic. So this is supposedly electrical signal because this is dotted line, this is wire. And here also we have the puncture valve. So this is the puncture valve. So the puncture valve, there is air travel here, the pilot air. So travel to the puncture valve to open the puncture valve. This puncture valve. If this puncture valve is not opening, so there is no fuel being pumped here. Because this puncture valve will open. Actually, this is the puncture valve is a combination of the suction valve and the puncture valve. So there's a system also, the fuel pump. There is suction valve separate on the bottom, and this is puncture valve on top. But there is also puncture valve which is combination of the suction valve. So in this fuel pump. This is puncture valve. So now you are ready. Now you start the engine. So the 30 bar also pressure, you see, when you put you see, this is starting distributor. So this is this distributor. When, for example, the timing, the cylinder number 1 will open. So cylinder cylinder 1. So this starting air distributor, this one, there is a hole. For example, a 7-cylinder engine. So there is a hole 7 here. So hole here, hole 3, 4, 5, 6, 7. So when the cylinder number 1 should be open, the hole here of cylinder number 1, the hole is 1, 2, and so on, up to 7, will open. This is rotary cylinder, for example, rotary distributor. So the pressure, you see here, this is air distributor reversing cylinder. When you open this control air to the telegraph, from the telegraph, the air will travel, here you see. So when this one will command ahead, so this piston will go there, and this one will open this area, this line. So the air will travel as to the distributor, you see, travel, and will open to the number 1 cylinder. So the pilot air will pass, and the pilot air allowed to pass and going to air start valve. So the air start valve piston here will push down, so the spindle in this area will open, and the 30 bar pressure, you see, the 30 bar pressure here will pass. You see, this is 30 bar. So the 30 bar pressure here will pass and will push down the piston. So you see, we easily understand the system when we use a diagram. So you cadets, students, always use the diagram and drawings when studying the system. So by reading the statement by reading the statement explanation cannot help you a lot. The diagram and the drawing can help you a lot to understand how the system works. So this is the way how we study. Do not memorize, but use always the drawing, analyze the drawing and the diagram. So we easily understand. So nobody, when I was studying, when I was a student like you, nobody teach like this what I did now. Nobody, my professor did not teach like this way. So it's hard to the student to understand. But this is the way I tell you that you can easily understand the system, how it works. So in the same way, when the bridge, so by the way, what is bridge? So bridge is the control of the ship in deck department. So the one who command there is the captain, and the captain will command to the engine room, and this is the command, the astern and ahead signal command. So when the bridge, the captain command to the engine room, to astern, so the engineer operate of the engine room. Now we are talking here in the engine side, so we are not talking the control room, but it is the same working principle. You just transfer the control to the control room or transfer the control to the bridge so that the bridge will operate. But now the engineer will operate here at the engine side. So when the bridge or the captain give the command to the astern, so the engineer will put this lever to the astern. This lever to the astern. So again, the pilot air will travel to the air start valve, and then the engineer. So when you stop the engine, you have to put the lever on the stop position. So as you can see here, the stop position is in vertical position. See, this is stop position, which is in vertical position. This one. So stop position, so the engine will stop. Now you put, now because of the command is astern, you put the lever of the telegraph. This is telegraph, this is telegraph. This is telegraph. Engine telegraph. Engine telegraph. So this is engine telegraph. So the signal is now in astern. So the engineer will put this lever to the start position. Then the signal, electrical signal here, will send to the governor. The governor, the fuel pump will operate. See, and the pneumatic signal or the air signal or the air pressure will going to the puncture valve and the suction valve here, so the pump will operate. So by the use of, by operating the engine now is turning, this one is camshaft, this one is camshaft. This is camshaft. The fuel pump will pump fuel to the engine through injector. So your engine, your ship will move astern or backward. So this is how your air starting system works. So again, another information, we have here the reversing. So reversing, here is reversing. When the command is astern, you see there is a reversing cylinder. So the air, when the engineer put the lever to the reverse, see the control air will travel the reverse. So pushing the piston there, so the engine will reverse. So what you control in the reverse, you see you have here the fuel pump reversing cylinder. So operating the fuel pump, the fuel pump reversing cylinder. So the camshaft, this one, the camshaft will shift to the reverse. So there are two position the camshaft. So this one, this position is forward. And this position of the cam is astern. So forward or ahead. And this one is backward. Forward or astern. So that is how you reverse the engine. So when you shift this telegraph to astern, the engine will reverse because of the position will of the cam will, because of this reversing cylinder will operate. You see here to the reversing mechanism. So when the cam is here, the engine will reverse, and the cam is here, you put the lifter here in the astern, so the engine will reverse, and you put the lifter here in the ahead of the cam, so the engine will move forward. So that is the reversing system. So I will stop this video now. Magawas kan? Buko? Di na lang ako stop si. Putin nyo na lang ako.
Ay, paano lang?
Magawasan ka?
Paano man yan?
Sige, stop na lang ako. So I stop this video now. We have here the starting air system also. So this can be also applied to the diesel generator. So we assume this is this system is used to the diesel generator. So the same principle. You have here the pilot valve. So this is pilot air. The same principle. This is pilot air. 7 to 8 bar. Pilot air. So you have here the air start valve. See? This is air start valve. This one. And you have here the automatic valve. So this is solenoid. So by analyzing this drawing, you just start from number 1. See? Number 1. So you have the local and start. Solenoid, just pause the solenoid. And you have also here the emergency. So emergency stop. Solenoid. Now, you see this is pilot valve here. When you pause this, we are assuming that this is used for diesel generator start system. So you have here the air tank, air receiver. So just open this valve. So from air receiver. So the air will travel. So see, air travel here, go there, travel there. Going here. So when you pause this local hand starting, allowing the air to pass in here. So going there to the solenoid valve. So passing here the turning gear, interlock. So if you will not release this turning gear, for example, this turning gear is engaged. So if this turning gear is engaged, so you can see this one here is this engaged. So if this engaged, the air cannot pass. You see, the pilot air cannot pass. See? So the air cannot pass. See? So you have 30 bar here. So the air cannot pass in here, you see. Pilot air, you see, pilot air. Control air, the 7 bar. If you engage this one, the air cannot pass. See, this is a small arrow in the pneumatic valve symbol now. But if you disengage this one, the air can pass. You see, the line is straight. If you disengage, the line is not straight here. The hole is not aligned to the air passage. So when this one is disengaged, now disengaged, so the pilot air, see, can pass here in the pilot valve per cylinder. So when the camshaft, this is camshaft, we'll push the lifter up. This is camshaft. This is camshaft. This is cam. When the cam rotates, here the lifter will push upward. So this is lifter, push upward. And allowing the pilot air to pass to the pilot valve going to the air start valve to push the piston down here. Then the spindle will go down, the air will allow to discharge here to push down the piston. Push down piston. So very simple. Very simple. Just always use the diagram to study. So at the same time, the fuel pump is operating or working. You see, air signal. So when you push the pilot air at the local hand start, the pilot air will push the rack, the fuel rack. See, this is fuel rack, and opening the fuel. So opening the fuel. So when the engine is running, now the governor is working. So the governor will control and compensate the fuel to the engine. So that is how the starting air works. So very simple. But when your first time, it is difficult to analyze. Now this is advanced knowledge for the cadets. So always use diagram when studying the system. Next. So let us proceed to the cylinder head. Cylinder head. A diesel engine cylinder head performs several functions. First, they provide the top seal for the cylinder or the cover of the cylinder, bore, or sleeve. Second, they provide the structure holding exhaust valves and intake valves where applicable for the four-stroke engine. Also, the fuel injector and necessary linkages. So that is the the construction as well as the function of the cylinder head. So remember all these are the basic, no, fitted on the cylinder head. Or the function, seal, you see, seal the cylinder bore or the liner. Second, so provide structure, provide a structure holding exhaust valve. So the exhaust valve is fitted to the cylinder head as well as the intake valve for 4-stroke engine. Fuel injector also is there. And necessary linkages. So this is the function of as well as the construction of the cylinder head. Next. So we have here cylinder cover. So what we call in the small AM is a medium speed engine, just like the diesel generator engine, we call it cylinder head. So for medium speed, diesel engine, we call it cylinder head. But for the low speed diesel engine, we call it cylinder cover. You see, this is cylinder cover. But we can call also cylinder head. So this is top view of your cylinder cover, top view. Later on we can see the actual picture. So again, by ordering the spare parts, so since this is main engine, the second engineer used to order the spare parts and submit to chief engineer. For example, here we order the let's say cylinder cover complete. Cylinder cover, we order also the cooling water inlet joint. So we locate the number here. So number 4. So for me, I want to order the, for example, I have no spare cylinder cover. So I want to order cylinder cover. So I will locate here number 1. So this is hole. This hole is cylinder cover. So I will order this cylinder cover. So I just write the reference number. So this is reference number. So number one is reference number to the requisition form, and I will write the description. So that is how to order spare parts to the company. So next. So here in this example, I will show you this example, parts of the cylinder head. So in this engine, this is this since the cylinder head here is this is used for small engine. You see, used for small engine. So the cylinder head is only one cylinder head. The assembly only one cylinder head because of this small engine. So the parts we have here the rocker arms. So this one is rocker arm. You see, this rocker arm. You have here the rocker shaft from here to there. Stud hole, the hole here, stud for the stud. So stud is the threaded just like a bolt but without head. Spring close valve, so you have the spring housing for thermostat. Take ports, the hole for bolting rocker arm. So just read what is the so valve clearance adjuster here. So just read what is written here. So these are the basic parts fitted on the cylinder. So we'll proceed to the next. So this is for small engine. Here we have here for main engine of the ship, which is we call cylinder cover. So this is cylinder cover. So here on top is exhaust valve. Cylinder cover is this one. See, this is this one is cylinder cover. So this one is cylinder cover or cylinder head. So cylinder cover or cylinder head. And this one is exhaust valve assembly. So exhaust. Assembly. So this is cylinder cover assembly. Next, we will proceed to rocker arm. So by the way, what is rocker arm? What is rocker arm in a diesel engine? A rocker arm is a reciprocating lever used in an internal combustion engine to transfer cam or push rod motion to a valve stem. So we have here so remember, reciprocating lever. Right? So it is reciprocating lever used to internal combustion engine to transfer cam or forced rod motion to a valve steam. So I will give you an example here. Illustration. So this is your cylinder head and this is your rocker arm. So this one is rocker arm. So rocker arm. So this is your rocker arm. So there is, it's not shown here, but there is a push rod in here, push rod. This is push rod. So when the cam, in here, there is a cam. Lifter, this is lifter, there's a lifter here. The lifter is pushed by the camshaft. This will move with a reciprocating motion. This push rod. Will push the rocker arm. So to open the valve in here. So these are the valve. This steam valve. You see, with the spring. So you cannot see steam valve, but it is inside here. So you have the intake valve. So here is exhaust valve. And here is the intake valve. So this rocker arm used to open and close the intake and exhaust valve. So that is rocker arm. So this is the actual photo. You see. So in this example, this is a two-stroke engine. This is two-stroke cruise head type engine. Cruise head type engine. So you see you have rocker arm in here. So this is rocker arm. And this is push rod. So when this push rod is operating, moving in a reciprocating motion, so up and down, by the rotation of the camshaft down below. So this is reciprocating motion. This rocker arm is pushed upward, then on the other side of the rocker arm will push the exhaust valve downward to open the exhaust valve. So this is exhaust valve. This is exhaust valve. That is exhaust valve. So that is the use of the rocker arm. So that is an actual photo. So nowadays, so this is for usually for the old engine, you know. So I work both of this engine, this rocker arm type and the hydraulic type. So this one, you cannot say rocker arm. Instead, the exhaust valve is operated by the hydraulic. So this is hydraulic. This is low oil pressure, hydraulic pressure, you see. So you can see here, there is a exhaust valve, cylinder cover. So this is a cylinder cover. This is a exhaust valve. See? And instead of push rod and rocker arm, this exhaust valve is operated by hydraulic pressure or low oil hydraulic pressure. So there is no rocker arm and push rod. So next, so this I work with this engine as well as in this engine also. So both of this engine I work. So we will proceed to the week number 6, which is the continuation of week 4. So the topic is still the basic construction of 2-stroke and 4-stroke engine. So we'll proceed to the exhaust valve. Exhaust valves open inwards. So meaning inwards, inside, going inside. The opening is going inside into the cylinder so that the gas pressure in the cylinder will ensure positive closing and help dislodge any build-up of carbon on the valve set. 2-stroke cruised engine have a single exhaust valve mounted on the center of cylinder head. So I'll show you this one. This is exhaust valve. So as you can see on the previous here, you know, the previous picture, you see the line. This one here. So here is the exhaust valve. So exhaust valve. So as you can see here, you have the spindle. So we have to open this spindle, valve spindle, you see. This is valve spindle. This one is a valve spindle. So here you have the valve seat, you see, the seat of the valve spindle, so valve seat. So this is your valve spindle. And here you have the cam. So you have the camshaft. So camshaft, this is the camshaft. Camshaft, see? So when the camshaft is rotating, this lifter, this one is lifter, will go up. So the pressure of the oil, you have here the hydraulic pump, this one. So when the pressure, when the lifter will go up, allowing this area will open. So the hydraulic pressure will travel to the pipe, you see, push down the piston here. So damping pin with clearance pieces. So there's a piston in here, operating piston. So this is operating piston, you see. Operating piston here, this one. The blue color. So when there is a pressure of hydraulic pressure here, low well hydraulic pressure, the spindle is pushed down. So why I know this? I work this one long time, this system. So you see, the exhaust valve will open due to hydraulic pressure. You see, hydraulic pressure. And the oil will drain here. So back to the tank. Back to the tank. So that is the operation of the exhaust valve. So we have also what we call the air supply, which is called spring air. So air supply here is what we call the ship. This is spring air. So spring air, when the camshaft is this side of the cam, this is the cam. It's not pushing the lifter. For example, in this position, not pushing the lifter. So this oil is closed. This oil line is closed. So the spring air will push again. The spring air will push again the piston upward. So push the piston upward. This piston. So push the piston upward to close again the valve spindle. So it will close again in this position, you see? This position. See, in this position. So when the spring, when there is no oil here, the cam is not pushing the lifter. So the oil passage here is closed. So the oil cannot travel here to push down. So the spring air will push the piston upward. so that this valve spindle will close to the valve seat. You see, close again. So there is also a system that there is no spring air, but there is actual spring in this area. The big spring here to close the spindle when the valve, the exhaust valve supposedly to close. So there is also a spring in this system, spring, the real spring. But if there is no real spring, we use the spring air. So there are two systems. So I will start this video for now. Let us continue. So let us continue with the exhaust valve. Modern two-stroke crosshead diesel engines have hydraulically operated exhaust valves which close by air spring. The cam operates a hydraulic pump instead of pushrod. The oil from the engine lobe oil system is displaced by the pump, which operates a piston on the exhaust valve, which pushes the exhaust valve open. Instead of mechanical spring, the valve has air spring at 7 bar pressure, is led via the non-return valve, is led to the underside of the piston of the valve. As the valve opens, the air underneath is compressed. So I already discussed the operation of this exhaust valve. So this is the explanation. So I already discussed the explanation, the operation of this exhaust valve. This is hydraulically operated. So I want to make it bigger, no? So this is smaller, so I want to make it bigger. So just make it bigger, this one. Smaller. So now become bigger. So it's not it takes times to save. So here we will continue. Instead of hydraulically operated exhaust valve, we have here the videos of the pushrod. So the opening and closing of exhaust valve is controlled by a cam mounted on a camshaft on the on older engines. The cam post the cam follower. Post rod is attached to the cam follower, which rises along with the cam follower and pushes a rocker arm. This rocker arm then pushes the valve spindle against the spring and the valve opens. After the cam has turned sufficiently, the cam follower sits on the base circle of the cam and then spring closes the valve. So we have here, I will explain to you. So instead of using hydraulic, so we are using rocker arm. So this is rocker arm. So we are using rocker arm. So this is in contrast to the hydraulic. Rocker arm. And this is push rod. And this is camshaft. And this is cam follower or lifter. So when the cam is rotating, you see, when the cam is rotating, the cam will push the cam follower upward, you see. And your push rod is pushing the rocker arm upward, the right side here. And the left side of your rocker arm will push the spindle downward, you see. This is your spindle. Valve. So the exhaust gas will release here from the cylinder. So when this cam is not on the right position to open the valve, supposedly this side is there, so the rocker arm will move down because of the push rod will move down again. So the spring, you see, you have spring here. Will use to close the spindle. So this one will close again. So it's simple. So that is the operation of the mechanical type instead of hydraulic type. So mechanical type, by the use of the push rod, cam follower, and rocker arm, the valve, the exhaust valve will open and close. So this is exhaust valve. This one is exhaust valve. So exhaust valve. So when you are an engineer on board ship, you have to order the spare parts for your maintenance, and repair. So by ordering spare parts, example, I order, so this is exploded view. So this is exploded view. when you order a spare parts, for example, spindle. So you see, you have here number 3. Number 3 is spindle. So valve stem or spindle. So you have here number 3, and you have valve stem or spindle. So this information you have to write to your requisition form. So that is how to order spare parts from maker. So through your company. So we have here it's not showing here the diagram. So this is used for small engine. This is a small engine. So you see you have a exhaust valve, intake valve, you have the combustion, you see combustion in here. So in the small engine, your valve, your intake valve and exhaust valve is opened by directly opening by camshaft. So this is camshaft, you see. You cannot see, so this is camshaft. You cannot see rocker arm here, and you cannot see also push rod, because your valve with your spring, you see there is a spring in here, is open directly by the use of the cam. So you see this is cam, this is cam, so directly pushes. There is no push rod, and there is no rocker arm. So directly. So this is applied for small engine. So 2-stroke. Two-stroke cruise type diesel engine. So this is two-stroke cruise type diesel engine. So as you can see here, this is hydraulically controlled. So hydraulic. So exhaust valve is operated by hydraulic. So as you can see here, your engine is running, you see. So this is your exhaust valve, you see. So when the pressure of oil, you see, this is the yellow traveling here. So when the camshaft So the camshaft is operating. Camshaft is here. So it gives hydraulic pressure, low boil hydraulic pressure, you see. It's moving here and pushing the exhaust valve. So the one closing the exhaust valve here is the spring. So it's not showing here. Spring air or the mechanical spring. So as you can see here, the exhaust valve is released to the turbocharger. You see? So this is turbocharger. So operating the turbocharger to suck air. So it's not showing here. This is only the operation of the exhaust valve as well as the combustion. You see there's a line of fuel here. The red one is going here. So this line here is lubrication. So I don't know why they put this one is red. It should be yellow. But anyway, this the operation of the exhaust valve for two-stroke crosshead type diesel engine. So as you can see here, your exhaust valve is opening and closing. So let us come to cylinder liner. Cylinder liner. The cylinder liner forms the cylindrical space in which the piston reciprocates. So here, inside here, the piston will reciprocate inside in the here, inside here. So this is your cylinder liner. Cylinder liner. So this is your cylinder liner. So you have parts of cylinder liner. So you cannot just install the cylinder liner without the O-rings. So you have here the O-rings. O-rings. You see? O-rings. So these O-rings will seal the cooling water. So you have the blue color here is the cooling water. So the cooling water will not leak outside. You have the lubricator drilling. So you have to install the lubricator here. So to lubricate the liner, piston rings. So you have to lubricate this part, as well as the piston. So you have water guide. So this is the liner. This one here. This in the center. This is your liner. So this is liner. This one is liner. So that is liner. So the piston will reciprocate in this area. The hole here is the scavenging port. So when ordering parts, so liner is subject for wear down. So you have to request this liner. So number one is cylinder liner. So if you are a second engineer, so you have to order this one. And you look at the reference number. look at the reference number and your description. So here is the part number. It's a part number. So you have to write in the requisition form. So you have to order a lubricator. So you have here the lubricator. So lubricator assembly, this is the part number, you see. Lubricator oil stud complete. So you just write this. If you order this one, for example, or by parts, or this one. So you just this one you order the whole assembly. So you just write the part number, you see. Part number in here to the requisition form. So very simple. So again, the operation of the exhaust valve. This is the operation of the exhaust valve. So it is explained a while ago. So you just rewind the video for the explanation of this operation of exhaust valve. Now let us come to cylinder head. So cylinder head, a diesel engine cylinder heads perform several functions. First, they provide top seal for the cylinder ball slave. Second, they provide structure holding exhaust valves, intake valves, where applicable, fuel injector, and necessary needed. So this is already discussed before. So we have here the cylinder head. So this is already discussed before. Just rewind the video. So in this, you see you have here the parts. The intake valve. So cylinder parts, you have the intake valve, exhaust valves, the guides, valve seats, valve spring, the head gasket, and the head bolt. So it is all here. So valve spring, this is spring, you see, spring. The guides is inside here, and the valve seat is inside here. You cannot see it in this drawing. Gasket is here, this area. Head bolts, so in this area here. Intake valves, so this one here inside, intake valves, exhaust valve here. So in ordering spare parts, here, this is for a small engine. So here you have what we call part number. So here is a part number. You see, as you can see here, this is part number. So part number. So it's not responding. And we have here for example, this description here. And you have so this one is description. Parts. And here you have the reference number. So very simple. You just write all this information. For example, you request this one, number 17. You need this one. So just locate number 17. You see, which is head bolt. and you write uh, to your requisition number. But in requesting, you have to, for example, you have to write the engine type. So engine type, this is very important. Or engine model. So this is the same, and maker. For example, B and W, or for example, Daihatsu. So that's the way how you order spare parts. So this is your main engine cylinder cover. So I already discussed this video before. So just rewind the video. This picture. So just rewind the video. In ordering spare parts, so it's the same now. So the same. For example, you have to order a cylinder cover complete. So take the reference number. Look at here, the part number. Here is the part number, and you have here the reference number, and you have here the description. So don't forget to write the model, engine type, engine model, and now let us continue here. In week 7, this is a continuation of week 4. The basic construction of 2-stroke and 4-stroke engine. So we have here the basic construction of stopping box. So I will the basic construction of stopping box, crosshead bearing, and crankshaft. Now we'll start for the stopping box. Stopping box for 2-stroke crosshead type marine diesel engine. What is stopping box in main engine? Stopping box, piston rod gland box, is a unique feature of 2-stroke marine diesel engine. It is nothing but a seal between crankcase and under piston space, scavenging space or scavenge space. Its function, it prevents the dirtying of the engine bearing oil by combustion residue. So we'll see what this statement means. So this is your stopping box. So this is scrapper ring. This is I forgot already, but this is the seal. All of this, and the stopping box, and this is the housing. So I think here there is a part in here. So I forgot to put the parts here. Because of the crankcase is separated from the cylinder and is cabin space by diaphragm plate on a two-stroke cruised engine, provision must be made for the piston rod to pass through the plate without oil from the crankcase being carried upwards and use cylinder oil contaminated from products of combustion being carried downwards. It is also highly undesirable to allow the pressurized air in the scavenging space to leak into the crankcase. So, there is red first here. The piston rod passes through stopping box which is bolted. The diaphragm plate, the stopping box is box casing which can be split vertically as shown in here. So in the photo contains a series of scrappy ring. Also this is scrappy ring and sealing rings. So this is scrappy ring. So this is scrappy ring. You can see the yellow color, the brass. Yeah. So this is scrappy ring or scrappy ring. And here this is sealing ring. This is sealing ring, which are each made up of 3 or 4 segments. On the outside of each segments is a garter. So of course there is a garter here to hold. This is spring, but here we call garter. This is spring. So spring garter. Garter spring which provides the tension to hold the ring segments against the piston rod. There is clearance between the segment to allow for wear. The rings are either bronze or comprised of replaceable cast iron lamella fitted into the steel backing ring. So segments meaning you have the cut here. So in this portion on the other side, so 3 cut we have here. We have the cut here. Yeah, this area and at the back. So 3 cut. So that is called segment. That is called segment. So remember that the function of this as stopping box not to allow pressurized air to leak to the crankcase. Is pressurized air in the scavenging space to leak into the crankcase. So that is the function. We'll see the next. So this is your scavenging space. In this area is scavenging space. Inundag something. So this area is scavenging space. This area. So this is your scavenging port. This one is scavenging port or the hole. So scavenging port. So here is your stopping box. So the one, this parts, this is stopping box. This is your stopping box. So it is installed this area. See, that is your stopping box. So as the piston rod passes up through the stopping box, the oil film of the crankcase is scraped off by the lower set of the rings, and it is returned via drillings to the crankcase. Any oil passes through the primary set is scraped off by another set of rings and is led away to drain to a telltale open ended pipe into the into a what is it? Tune disc outside, and the engine from where it is drains to a recycling tank. So in here, in the stopping box here, let's see, the oil is being scraped. So this is the purpose. So in here, so the oil is scraped. This is your piston rod here. So the oil is scraped. So it will return the oil to the piston rod drain tank. So here, there's a tank. So the oil will return here. No, when there is a leak, piston rod drain tank, when there is a leak, it will going to be to piston rod drain tank. If this scrap ring is seal ring is leaking, but if there is no leak, the oil will return to crankcase. So this is this arrow here. So return. So oil return to crankcase. So that is the purpose of stopping box. So as the piston passes down through the stopping box, the top set of scrap rings will scrape off the contaminated oil into the bottom of the scavenging space where it is drained away via scavenging drains. However, if these rings are faulty, then the oil may be drained into the recycling tank. So here, this is a recycling tank, the piston rod tank. Piston rod tank. So remember, we will not allow the oil, because this is bearing oil, this is engine oil, or the oil here being scraped here is system oil. So system oil or bearing oil. So we don't want that to consume very fast, because that is the system oil of your engine. So we need to overhaul this. There is a running hours of this stopping box to overhaul. So next, by observing the open-ended telltale referred to the above, a guide or the condition of the rings can be ascertained. So you know the condition of the rings. Where there is already a lot of leak. So I monitor this one by sounding the tank, the piston rod tank. So if a large quantity of oil is drained out, so of course there is the called telltale is sight glass. So you can see if there is a leak of oil. So of course to sounding also the tank to measure the piston rod tank, the content, to monitor, so you will know that your stopping box is already leaking. So if a large quantity of oil is draining out, then the lower set of rings are faulty. If air is blowing out to the upper rings are worn. So the upper rings, which is a scraper rings, is used to seal the air from scavenging. What I mean is here. So the upper rings here, this one here, the scraper ring, used to seal the air, and the seal ring down is used to seal the oil. So oil in the recycling tank or the stopping box tank or scavenging tank can be purified back to the crankcase. So this can be purified, but the only problem here is the color of your oil is very black. So it doesn't matter the color, but if it is will pass to the test, low oil test, it is still okay. So however, this is not necessarily a good idea. So this is correct. It may be contaminated by the used cylinder oil, yes, which mixed with the crankcase oil causes an increase in viscosity of the crankcase oil. So this is correct. Calcium deposits in the bearings oil lead to damage, and the oil may be carbonized and deposit on the underside of the piston crown when used piston coolant. So often this contaminated oil is just landed ashore or born. Regular maintenance of the stepping box will keep in a good condition, checking garter, spring tension, and ring, but the axial clearance and the replacing worn rings are all part of the overhaul procedure. So excessive wear will take place if the crosshead guides are out of alignment, or if the guide clearance are excessive, or stopping box and excessive leakage can exacerbate the evidence of scavenging fires and increase the risk of case explosion. So here, the leak oil here is not advisable to, but you can purify. So what I did when I had a trouble before, this trouble, the leak of the scavenging, the stopping box, sorry. So I returned to the crankcase because I monitor it is the leak was 20 liters. I think 20 liters per 2 hours. That is too much. So even I already overhaul, there is still a leak, a lot of leak. So I return the oil to the engine. So because it is consuming a lot of oil, but it is not advisable to do. So now we are done with the stopping box. By observing here, we will proceed to the crosshead. So what is crosshead? A crosshead is a mechanism used as a part of a slider crank. Linkages of long reciprocating engines. So this is long reciprocating engines and reciprocating compressors to eliminate sideways pressure on the piston. Also, a crosshead enables the connecting rod freely move outside the cylinder. So crosshead. So this statement we can see here. So this crosshead type B, this is two-stroke. Two-stroke. This is two-stroke. Two-stroke. Crosshead type diesel engine. So we will see here. You see the crosshead. This is the crosshead. This is crosshead. So the function of the crosshead. So it is connected to the connecting rod and also connected to piston rod. So as mentioned here, so slider linkages along, so sliding. So this here is the guide. So here is the guide. So this is sliding. This crosshead. So crosshead and crosshead bearing. So crosshead bearing is inside. So sliding. Here is slider crank linkages of long reciprocating engine. So this is long reciprocating engine, two-stroke crosshead type diesel engine. And reciprocating compressor. So it can be also applied to the compressor to eliminate sideways. So it means eliminate sideways because there is a guide in here. So you eliminate the sideways. So sideways motion. So it is eliminated because there is a guide in here. crosshead enables the connecting rod freely to move outside the cylinder. So, you see, the cylinder is here. So, you have the cylinder is here. Cylinder is here. Here is your cylinder liner. So it is moving. Your connecting rod is moving outside in the cylinder because of the piston rod and the crosshead linkages. You see. So the connecting rod is moving outside in the cylinder here. So we will see here. You see, this is the movement of your you see, this is the crosshead moving. This one is the crosshead. So here is the guide. So you can see the connecting rod is outside. So moving your connecting rod outside the cylinder because the cylinder is here. So that is in this video. You can see how your crosshead is moving. So this is crosshead. Remember, this is crosshead. This is crosshead bearing. This is crosshead bearing. This is crosshead bearing. So this is upper bearing and this is the lower bearing. Crosshead upper bearing and crosshead lower bearing. So this bearing is subject for inspection. So this subject for what we call the CMS. So CMS continuous. Survey. So this is subject for continuous machinery survey. This is CMS, and this is approved by. So approved to be approved by class surveyor. So class surveyor will give CMA certificate. So the one who will do this one is alternate. So every next survey, for example, next survey is the surveyor will make the survey, and the next survey also, the next approval is the chief engineer. The one will do the inspection is the chief engineer. So that is the role of the class. So that's alternate. So the chief engineer will make report for the survey, either bad condition or good condition. Either you replace the bearing or you put it back, put with the same bearing. So it depends on the condition. Next, we will proceed to the crankshaft. So what is crankshaft? A crankshaft is a rotating shaft which, in conjunction with the connecting rods, converts reciprocating motion of the pistons into rotational motion. Crankshafts are commonly used in internal combustion engines and consist of a series of cranks and crank pins in which the connecting rods are attached. So we'll see the picture here. So this is crankshaft. So here is the counterweight, the crank wheel. See. So here is the you have the main bearing here, and here you have the crank pin bearing here, and here you have the flywheel mounting flange. So this is the crankshaft. So it says here converts the reciprocating motion. So reciprocating motion of the piston. So reciprocating motion of piston convert to rotational motion of the crankshaft. See? Reciprocating motion of the piston into rotational motion. So crankshaft will have now a rotational motion. So normally it is so clockwise. So like this. But there are ranges also there are also engine, but rare. They are rare. So they are also counterclockwise. So counterclockwise is applied to the twin engine propulsion. So this is crankshaft. Piston, reciprocating motion of piston convert to rotational motion. Of crankshaft. So that is the role of the crankshaft. So we have here what is the main difference between the inline engine and the V engine. So the main difference between, so I will proceed in this topic. The main difference between them is in how, so it is referring here the inline engine and the V engine. Is in here how the cylinders are arranged. Inline engines have the cylinders in a straight line, while the V engine has the cylinders grouped into two banks and arranged in V at a certain angle. The arrangement leading to the name of the engine configuration. So we have here the B-type engine, you see. As you can see here, the piston form B. So the piston is inside the cylinder. So the arrangement of cylinder is B, form B. So this is B-type engine. Inline engine, as you can see here, this is in a straight line. So straight line. So this is the keyword. The keyword of the B-type engine is the arrangement of the cylinder is in the form of V at an angle of 60 degrees and 90 degrees. 90 degrees. So it depends on the engine configuration. So inline type engine, the keyword is there is the cylinder is in the straight line. So as you can see here, this is vertically arranged in a straight line, the piston. So the piston is inside. So you just imagine there is a cylinder head there, and this piston is inside the cylinder. So the arrangement of the cylinder here is in a straight line, which is called inline engine. There's what we call also a flat engine. So what is flat engine? Flat engine is also known as horizontally opposed engine. It's a piston engine where cylinders are located on either side or of a central crankshaft. So this is called also flat or boxer type engine. So I did not experience this engine when I was working on the ship, but this engine, as I know, this is used in the SUV vehicle. So the Subaru SUV vehicle, the engine is flat engine or boxer type engine. So this is in one side, the horizontally arranged in one side, but we can see also this engine with this one, the opposed engine. So they are the same, but this one is the cylinder is arranged in only one side, but it is arranged horizontally. But here, this arranged horizontally, but both sides. So the left sides and the right side cylinder. So just imagine here, there is a cylinder here, because the piston is inside the cylinder. So you see. So this is flat or boxer type engine or opposed engine. So I will end my discussion here for this topic, and hope to see you in my next video. So if you found this video helpful to you, so if you have a knowledge, if you acquire knowledge with this video, so please click subscribe, click also notification button, and thumbs up. So hope to see you on my next video.